futures. We embrace the vision of nurturing not just educators but visionaries who mold the future of education. Welcome once again. Now I would like to request Dr. Leena Daniel, HOD EX, to extend a warm welcome to our guest, Dr. Kumar, with our sapling. Thank you, sir. Thank you, ma'am. Dr. Anil Kumar has been awarded from postdoctoral fellowship from Energy Technology Research Center, Department of Mechanical Engineering, Faculty of Engineering, Prince of Songkla University, Thailand. His research interests in the areas of energy technology, renewable energy, solar energy applications, heat transfer, natural rubber sheet drying, and their environmental issues, natural resources management, and techno-economics of energy systems. He and his collaborators have worked on solar drying systems and established the characterization technique for such systems. He and his research scholar have also developed a thin layer drying model, Prakash and Kumar model 2014. Recently, an energy efficient north wall insulated greenhouse dryer with solar collector inside was designed, fabricated, and tested by him. Featured in the world ranking of top 2% of scientists created by Stanford University since 2019. He has published 12 books and more than 350 plus papers in national and international journals and conferences. He is actively involved in several sponsored research projects and has supervised 10 PhD and 45 master students. He is recipient of Research Excellence Award 2016, honored by President University, Thailand. Recently, he received the Research Excellence Award in 2019 from Vice Chancellor DTU Delhi. He also received the Best Paper Award at Global Conference of Energy and Sustainable Development. Dr. Kumar has visited countries like UK, Thailand as an academician and researcher, and a personal visit to Malaysia. Let's warmly welcome Mr. Kumar to the stage with a round of applause.
Thank you, madam. Am I audible?
Yes, sir.
Yes, sir. So, no need for this mic or speaker. So, and basically, madam, I'm a teacher. So, I used to teach the 120 student class. And so, I think I'm audible. Then, is it needed or not?
Yes, sir. What takes you, sir?
Okay, then fine. If you suppose not able to understand means not able to listen my voice, then I will take in my hand. Otherwise, it is a kind of engagement. Madam, can you show this slide? Yeah. Thank you. First of all, I would like to thank SISTec Group for inviting me for this talk in recent 1 week faculty development program, recent advancement and development in electric vehicles and renewable energy technology under ATAL training and learning academy. And especially I would like to thank Professor Serena Daniel. She was in touch for a long time and for inviting and gave me once again chance to interact with you. And in fact, in this year itself, I visited this college, SISTec Group, in January only. So thank you, madam, for calling me again over here. So happy to see most of you are student, and in fact, these all talks or means discussion are definitely it is helpful to the student only. So for their minor or major project, and 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 based on that they can decide. Based on that they can decide what is recent trend right now. Okay, and this EV the electric vehicle or battery operated electric vehicles are very burning topic now these days. And as all of us know about the situation of environment, right? So we have to protect our environment. And a lot of, and in fact, government of India is supporting in many ways to protect our environment. Our Prime Minister have already announced many schemes for whether this is related to installation of rooftop installation of solar photovoltaic systems or other kind of the renewable energy systems, right? For the and of course the promotion for the electric vehicles, the various state government have already taken some initiative, and government of India is also. And many states have already announced few schemes, but fact is, actually right now, electric vehicle. If suppose the electric vehicle is there, term electric vehicle, what what thing comes in your mind? बताएंगे? फिर स्टार्ट करेंगे. इलेक्ट्रिक व्हीकल अगर है, मैंने बोला, मुझे समझ रहे हैं ना? अगर हम बोल रहे हैं कि इलेक्ट्रिक व्हीकल, राइट? तो क्या स्ट्राइक कर रहा है?
Pollution free and environment.
Environment, emission free
environment.
Okay.
Noise pollution.
अरे ये तो पॉजिटिव एस्पेक्ट्स. कुछ ऐसा बताएं कि means some hurdles for the implementation or make it more familiar. What are the problems? चलिए यही सब हम डिस्कस करेंगे, ठीक है? So madam has given me responsibility for the role of renewable energy in sustainable development of electric vehicles. So means I'm going to talk about some fundamentals regarding the electric vehicles, the trade, markets, and few countries like China, Japan, and Korea, and in fact the USA, they have already implemented this policy, and in fact India also. But some data, we will discuss about some data itself. Then in the second half, I would like to connect with you the electric vehicles and the importance of the renewable energy resources in electric vehicles, right? Because what happened, right now electric vehicles are so. I would like to listen by the time that means the charging, right? So in the promotion of electric vehicle, the major constraint is the charging stations. Okay, and charging right now, the charging of electric vehicles, how we are doing either by the domestic type chargers are there, means commercially availability, availability of commercially these charging stations are very less now in our country. Okay, and in fact, Delhi is a metropolitan city, but there also I have observed. I'm from Delhi, the Delhi Technical University. Even in Delhi, the very less charging stations are available, right? And in fact, charging is done by conventional energy sources, right? Okay, so this is right. What we are doing is at present, we are just shifting emissions from one place to another place. Okay, fine. So power is most of the power means almost 57% of power comes from fossil fuel, and overnight we cannot change because what happened, as you know, the energy is basically energy consumption. The per capita energy consumption is indication of prosperity of any country, right? And the development, it shows the development, and in fact it is directly related to the human development index. Fine. So overnight we cannot change. In fact, right now most of the place, I'm not talking even one or two places, maybe the charging station is operated by the solar photovoltaic system. Okay, but most of the place charging is done by the conventional energy. Okay, so what we suppose in Delhi, what we are doing, and yeah, one more very important thing is transportation sector itself contribute more than or say around the 30% of the emission contribution from the transportation sector only, right? So only conventional energy means fossil fuel based power production is there, and roughly per unit electricity generation produce 0.98 kg of CO2, right? So this is, and in fact, we are just shifting. Okay, from somewhere the power is producing with the help of the fossil fuel, and although in India, as per the data, the recent data, the renewable energy sources in installation, the total how much total installation capacity in India right now? 400,000, 4 lakhs megawatt, right? And it's 40% installation capacity is from renewable energy system, renewable energy sources. Okay, but major problem with the renewable energy is the power. Okay, so how many of our system power plants, renewable energy based power plants are working nicely? So this is another problem. Okay, so so in fact, just look at with this picture, and what you will see, the wind energy is there, solar, biomass, okay, and then plugging is there. Okay, so my talk is concentrated within the renewable energy, and how the renewable energy can be implemented is helpful for the sustainable development of electric charging system, electric vehicle development. Okay, so in that I would like to cover the following things, following topics: electric vehicle trains and electrical technology, SWOT analysis, strength, weakness, opportunity, and threat, and electric vehicle charging, how do we charge, policy, role of renewable energy source in sustainable development, importance of sustainable development and existing renewable energy source in EV application, and the integration of renewable energy in the EV. And in between, I would like to talk about the green hydrogen. Green hydrogen, the production of the green hydrogen, because ultimate solution is fuel cell based vehicles. Okay, because EV, though we have the very many benefits, but we have few problems. The discard of battery is a major problem, right? So for that, few terms are very important: energy density, power density. Based on that, and in fact, we have to concentrate on weight, volume, and cost. Okay, so so what happened? So the cost per kilometer, cost of running cost per kilometer is a major problem. Okay, have you ever think about, like, generally when we go to for purchasing a vehicle, we generally say कितना देता है, ऐसे बोलते हैं, mileage, how much mileage is there, 15 kilometer per, but have you ever think about electric vehicle, whether this is more efficient or less efficient in terms of, so in that basically you have to very much careful about the decision before taking decision of electric vehicles, the depreciation cost, interest, because what happened, the battery replacement is there continuously, but in case of the conventional vehicle, what is happening over there, fuel tank is there, but you are not going to replace the fuel tank every time, right? So, but the battery replacement is in every 3 years or 4 years, at the most the 5 years, not more than the 5 years. After 5 years, you have to replace the battery, and the cost of the battery is around in between. It varies the 15 to 12 to 15,000 per kilowatt. So roughly the cost is around 70,000. It varies 50 to 70,000. The cost and replacement of the battery, right? So this is major thing, and after that, the waste is there. How you will control, right? So these are some problems. Anyway, so yes. So later on, EV vehicle or electric vehicle based on the hydrogen fuel cell is the will be the future of in the transportation industry. And in fact, the government of India is also taking a lot of initiative with the help of some other this IUCL and NICE. Okay, okay. If you have any problem, just please discuss to me. And so okay, so I will concentrate on this. Is it visible or shall we close this? It's okay. Acha. Now just see the sales. Electric car sales. I will show you some statistical data. So how the market of the EVs is rapidly increases. Okay, not only in India, around the world. Okay, so in fact, it is need of the present agenda, right? So in the from 2010 to 2013, see the how the electric car sales is keeps on increasing in the last 10 years, right? This red portion is China. As China, definitely China is the topmost country in the world for initiative, for selling, for promotion, for everything related to the electric vehicles. And in fact, they are number one country for producing the most cost-effective electric vehicles, right? So then Europe and USA also, and this great portion is for the rest of the world. Okay. This is in terms of the million basically over there million and this is billion, right? So I will read these basically statistical data. Over the 26 million electric cars on the road in the 22. See, in fact, if you remember during COVID period, you might have observed this what atmospheric conditions, right? You might have observed the atmospheric condition. How was that? It was much more clear than earlier. देखा था ना blue sky, है ना? From Delhi, people were claiming they are able to see this Himalaya also. सुना होगा ना न्यूज़पेपर में हिमालय दिख गया, कि तिब्बत दिख गया, है ना? सुना तो होगा. So that was all because on road there were no electric vehicles were not available, were not running, right? Almost all the transportation was stopped. So basically just look at over there. So by that from that itself, people realized that this vehicles, whether this is two-wheeler, three-wheeler, four-wheelers, passenger vehicles, basically they contributes a lot emissions. Okay, so and in fact in the urban area, so this there is huge emission because of this transportation, right? So this all story is between the 2019 and 2020. So over 26 million electric cars were on the road in the 2022, up to 60% related to the 21. Just see the increment within 1 year. 60% increment within 1 year and more than times in the stock in the 2008. The electric car sales exceed 10 million in 2022, and it was the increment of the 55% and related to 2021. Sales in China increased by 80% and accounted for 60% of the global growth. China is the topmost country which is promoting the electric vehicles. Just see, the sales in China increased by 80% and accounted for 60% of the global growth. The growth in Europe remains very high, 15%, and accelerated in the United States is 75%, right? And for 1 year, I remember in between the 2018 to 19, there was some decrement in the sales of in the USA in electric vehicle. So monthly sale in the electric cars have been steadily increased in the United States with the further growth expected in the 2023 as a result of the strange policy support. Okay, the number we will discuss all policy implemented by the all major countries: China, Netherlands, Norway, okay, India. So we will discuss later on what policy they have been implemented for the promotion of this. Number of electric car model raised, especially for the large car and SUV at the same time to decrease in conventional car. Yes, in India, can you guess or if you have the exact information? So what kind of the vehicles are being moved? Two-wheeler, three-wheeler, four-wheeler, passenger car, commercial, or what kind?
I would say commercial.
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 Maximum commercial vehicle. Two-wheeler. And in fact, the two-wheeler and three-wheeler accounts almost the 70%. Right? I'm talking about the India one. Okay. In the Europe, the situation is different. Okay. So, in fact, the number of availability of electrical model, which is the 500. The 500 times 500 electrical model cars are available in 22, but it is large car and SUV still account the half of the. And in fact, one more thing is I want to highlight over here. People generally prefer the cost in terms of the cost. It is less than the 1 million, or in between the 0.5 million to 1 million. Means 5 lakh to 10 lakhs. Okay. So middle class people, they generally have the range of purchasing this electric vehicle, and they have the choice. They generally choose in between the 5 lakhs and 10 lakhs. Okay. So in India, in this electric car segment, you will find the many models in between the 5 lakhs and the 10 lakhs in between. So more than 10 lakhs are also over there. But but the sales is very less. I will share some data related to that also. Okay. In 2022, the seventh country had around the 150 EV models, but in 2018 it becomes 500, increasing more quickly than the smaller model. Okay, so battery electric vehicle passenger remains much cheaper in China, which explains the far higher adoption rate there. And regional trade and the development, there was notable boom in the electromobility in 2022 in India, Thailand, and Indonesia. And this is because of government technology. Okay, collectively sales in the electric car of these countries more than tripled related to the 2021 and reaching 80,000. The sales in the 2022 were seven times more than in the 2029 and before the COVID pandemic. Okay. Now look at over there. The Maharashtra is a top means in terms of the EV sales and in terms of the EV sales, the Maharashtra is the topmost state in India, right? And after that Gujarat, then Uttar Pradesh, then after that Tamil Nadu. So like in that way, just to see this sales data up to January 2022 is like that. Okay, so and in fact, another slide. This is in Delhi. Yeah, I just want to highlight Delhi also. 19,000. Okay, so people definitely attracting toward the electric vehicles. Okay, but anyway, this FDP is for good things about EV. So I would like to concentrate on the good things. Okay. Anyway, so see, in India, the battery electric vehicle sales reaches up to 50,000 in 2022 and 4 times more than 2021, and while the total car sales increased by just 15%. The leading domestic manufacturer Tata accounted for over the 85% of the battery electric vehicles. So, which one is the first electric car in India? कौन सी है? बताओ भाई.
Tata Nexon.
Next.
Next.
जो ज़्यादा पॉपुलर हुई. People are and in fact, India this plug-in hybrid electric goes to zero. Acha. So upcoming the electromobility company are new getting the government production linked incentive. Production linked incentive scheme with around the 22 million USD in subsidy program in the way of ramp up the EV and component manufacturing. This scheme has affected the investment totaling 8.3 billion USD. Okay. So, see, the current market focus India under this India market is currently oriented towards the share and smaller mobility. Electric car purchase in this in 2022, the 25% of electric car purchase in India were made fleet operation and particularly for the taxi. भोपाल में कितनी देखी है आपने इलेक्ट्रिक व्हीकल इलेक्ट्रिक टैक्सी है भोपाल में अभी स्टार्टिंग में एक बात
We have electric cars, but I don't think so. We have electric.
Ola,
taxis.
Uber, or one blue taxi is there.
No.
E-rickshaw is there.
Yeah.
But
Not in a four-wheeler. We have three-wheelers here.
No. I am asking regarding this cab or taxi.
No, we do not have that.
Okay. So in Delhi, these electric vehicles have started in the cab. And so now the electric vehicle purchase is taxi. The Tata Uber deal is there. The Tata secured a significant amount of Uber and 25,000 electric vehicles in early 2022. Three meters and car sales are 55% of the 3-wheeler sold in the electric and less than 2% car sold in this. Okay. And Ola, I just want to highlight over the Ola plans to build the lithium-ion battery manufacturing facility starting from the 5 GWh and scaling up to the 10,000 GWh. So such kind of initiatives or basically this is market trend. Okay. Now I would like to discuss the EV. However, I know this is I think the fourth day. Already many experts have already discussed about this technology, but for my understanding and before going and connect my next talk, so just I want to discuss all these things. Okay, so over here the electric drivetrains and solar analysis, right? So different kind of the electric vehicles are there: battery operated vehicle, plug-in, hybrid. Okay, so what I think I'm sure in the last 3 days all of these things have already been covered. But again, I just want to, for my satisfaction, battery electric vehicle. What is that? So basically, in the battery operated electric vehicles, so battery pack is there, an electric motor, and then one more system is as like conventional vehicle transmission systems, right? But over there, this is very important thing: the electric motor. Okay, electric motor and control system for the electric motor, and this is very important part. And in fact, how do we decide the capacity of electric motor? That all depends on weight. Okay, and there are many factors for designing the electric vehicles, like on road resistive forces there. In fact, the tires. Okay, for electric vehicle, the tire design of the tire should be very different. Okay, the different kind of the tire has to be used. Another thing, by और क्या हो सकता है? Aerodynamic shape, to minimize further this resistance. Okay, and मोटे-मोटे तौर पे हम बात कर रहे हैं. And another very important thing is weight. How do we reduce the weight? Okay, and how do we reduce the weight? And in case of the electric vehicle, the major weight is from the battery. Okay, the battery. And in fact, one more important factor is the maintaining the environment of battery combination. That battery system is there, huh? So you have to maintain its environment. Proper cooling must be there. Okay, these are the three factors which depends on the electric vehicle efficiency. However, when we talk about the bell to wheel, can you understand bell to wheel? So, bell to wheel means raw material or the fuel. I'm just talking over here regarding fuel only. Okay, how the battery vehicle life cycle assessment you can do for electric vehicle or any kind of vehicle. Okay, but here I am just talking about in terms of fuel only, right? One fuel is electricity, another fuel is crude oil or gasoline. Okay, so you just please compare from where the crude oil is there and the gasoline up to gasoline, the conversion efficiency is there, and from fossil fuel to electricity, or it is a combination of the electricity is a combination of fossil fuel as well as electric. Okay, then these are the two stages of both these conventional and electric vehicle. Fine. One is fossil fuel to electricity for electric vehicle, one stage, and in case of the conventional vehicle, fossil fuel to gasoline. Fine. And second stage is from electric wheel to power producing at the wheel. Okay, in case of battery vehicle and for the conventional type of vehicles from gasoline to power available on the wheel. Right? So just guess which one is more efficient. बताओ भाई which one is more efficient. देखिए मैं रफली एक आइडिया दे रहा हूँ आपको. On an average, what is the efficiency of power conversion system? Not more than 30%. Okay. Or gasoline 27%, 26% from transition phase. And now electric vehicles are more efficient from once the electricity is available, then you have to convert into the rotary motion. Okay, so almost you will find 98% efficiency conversion efficiency is there from electrical to power available at the wheel. But in case of the conventional fuel, the gasoline, this IC engine efficiency is not more than 35%. Fine. So in that term, in overall, you will find the electric vehicle efficiency in case of the belt to wheel is higher as compared to the conventional. Of course, it will be higher. Okay. So this is the positive things. And yeah. So electric motor, inverter, battery control module, these are the main components in case of the battery electric vehicle. And what are the key features? The fully powered by the electricity, also known as all electric vehicle, more efficient than the hybrid or plug-in hybrid. Why it is more efficient than we will discuss later. Okay, so different models are available. This NTZ, Tata Nexon, Tata Tigor, Mahindra E20 Plus, Hyundai Kona, Mahindra Vertigo. Okay, so very simple arrangement is there. Only battery pack, electric motor, and then the transmission device. And in fact, transmission device definitely because I'm from the mechanical engineering background, so the transmission system, although some of the people generally now the conventional vehicles are converting into the electric vehicle for testing, for the research or some lab point of view. Okay, and some experimentation in the lab. So that is fine, but tires and the transmission systems are entirely different. Should be entirely different for the electric vehicle. Okay, so and by this way you can reduce the overall weight of the electric vehicle. Okay, electric vehicle. So what is next? The hybrid electric vehicle. In the hybrid electric vehicle, you will have both fuel tank as well as battery for engine. Okay, and the primary basically, in fact, over there the electric motor and battery storage there. What do you understand this hybrid electric vehicle? तो बताएं मुझे. आजकल बहुत सारी मारुति है वो हाइब्रिड लिख देती है पीछे. क्या है उसका?
Has both motor as well as engine.
Yeah, but basically the electricity we are not providing from the outside. So whatever the power is developed, that is based on the IC engine. Okay, that is being utilized. This is the main difference. And in fact, the engine, electric motor, battery pack, petrol, inverter, tank, and control volume. So only the fuel tank and engine, this is IC engine, the okay, conventional devices are over there. The both IC engine, the battery power motor power train is used when battery is discharged, and battery is discharged, IC engine drive as well as the charge of the battery less efficient, the fully electric and plug-in is. Okay, so basic. Okay, so what is happening over there? We are using the gasoline only. Gasoline means we can be use the CI this diesel also. Okay, okay. So this is plug-in type hybrid electric electric vehicle. The main component electric motor, inverter, battery, fuel tank, control module, the battery charger, battery charger. Okay, but here we have to charge this from the conventional energy itself, or from the electricity. Fuel tank. These are also known as the series hybrid and have both engine and motor. Any fuel, either conventional or alternative, can be selected. They can be powered by the externally recharged battery pack and can be run at the least the 2 electric vehicle. So this is up to your choice. Okay. मैं इसलिए बताऊं जी आप इस 2 year back, 3 year back, I went to purchase one vehicle. अच्छा मैं नाम नहीं लूँगा यहाँ because recording is there, है ना? But company by the time in Indian market only one company was there. Okay, so I am मैडम ने बताया कि I am from the energy background. I used to teach energy conservation, solar energy, renewable energy. तो मैंने भी सोचा मेरे भी मन में आया कि यार हम भी थोड़ा सा जब पढ़ा रहे हैं लोगों को टॉक भी दे रहे हैं, क्यों ना हम अपने इलेक्ट्रिक व्हीकल ही ले लूं, ठीक है? तो अब इस इलेक्ट्रिक व्हीकल में by that time some problem were there. Major problem was company was claiming 200 in single charge 210 kilometers. I'm from Aligarh, UP, and from DTU to my home it is around 170 kilometers. मैंने फिर एक टेक्नीशियन से पूछा लोगों भाई ये बताओ कि सिंगल चार्ज में मैं अलीगढ़ पहुंच जाऊं 170 किलोमीटर, उसने काम बोला कि सर बिल्कुल नहीं पहुंच पाऊंगा. तो और इन बिटवीन बीच में भी फिर मैंने सोचा कि भाई मैं ये तो देख लूं चार्जिंग स्टेशंस हैं कि नहीं, ठीक है? एक भी चार्जिंग स्टेशन नहीं है अलीगढ़ और बीच में. फिर मैंने सोचा चलिए अलीगढ़ में देखो, तो अलीगढ़ में एक चार्जिंग स्टेशन था. So 3 year back such kind of problems were there. अगर लेना भी चाहे आदमी तो भी ना ले पाए. चार्जिंग स्टेशंस है ना, और if you are charging from, मैंने पूछा भाई in Delhi it is very difficult to purchase your own house, means land. I am residing in the flat only, and it is and by the time I was residing in the DQ campus, so maybe after some time I purchased and I moved somewhere else. So acha, charging installation the company people will do only charging plug and other things. Okay, and for domestic charging will take lot of time for complete fully charge for the vehicles. That was another problem. Domestic. So some special type fast charging, there is a need of fast charging stations also. So within 15 minutes, within 10 minutes, just plug in and fully charge. Like in Japan, Korea, China, right? So वो अभी development अभी हमारे country में होना बाकी है. Anyway, so there so many models are available for the BMW and many Hyundai, Kia, Audi. Okay, so plug-in hybrid electric vehicles are developed. So I was talking about this. This is only the future. After all, the people will shift to fuel cell electric vehicle. Okay, so what is that? So hydrogen tank is there. Okay, fuel cell, then this control device, battery, electric motor, like in this. Okay. अब यहाँ पर एक क्वेश्चन आता है, whether this is such kind of a fuel cell electric vehicle is completely emission free. बताओ भाई. Now बच्चों, मैंने कहा it is completely environmental friendly device or vehicle, fuel cell based. हाँ बताओ। अरे भाई हम बात करने आए हैं यहाँ पर, ऐसा थोड़ा एक दूसरे के चेहरे थोड़ा देखेंगे। कोई बात नहीं, बोलो जैसे क्लास में बोलते हो ना वैसे ही बोलो, इसमें कोई शर्म वाली बात नहीं है। अच्छा चलो कोई बात नहीं, है ना। इमिशन क्या होते हैं? कन्वेंशनल व्हीकल नॉक्स, सॉक, ठीक है, कार्बन मोनोऑक्साइड, कार्बन डाइऑक्साइड, राइट, एल्डिहाइड्स आर देयर, पीएच एल्डिहाइड्स, है ना, यही होते हैं ना, ठीक। एक और ग्रीन हाउस गैस में एक चीज और आती है, दैट इज वाटर वेपर। वाटर वेपर इज आल्सो greenhouse gas. It is there. Okay, water vapor is byproduct. Okay, so however, in case of the electric vehicle, there is no emission at the tailpipe, from the tailpipe. Okay, so वो बात बैटरी अगर भी इसकी बात करते हैं, right? So there are many companies, the Toyota, Hyundai, Honda. They have already produced this fuel cell based electric vehicle. In India, one vehicle I remember in the NICE, National Institute of Solar Energy, another vehicle running in the campus of IUCL left in Faridabad. Okay, two I remember. Other than that, I don't have idea. So, what are the main components over there? The electric motor, fuel cell state, hydrogen storage tank. This there are a lot of changes for design the hydrogen storage tank. I will discuss, because I will after this section I will start hydrogen production, right? So over there I will discuss more about the hydrogen storage tank and battery converter and controller. So these are also known as the zero emission vehicles. But अब आप कहोगे यहाँ तो लिख रहे हो आप zero emission, और बोल रहे हो आप zero emission नहीं है ना, लिख जरूर रहा हूँ यहाँ पर, but it is not the zero emission. The fact is because the byproduct is water vapor. Okay, so and water vapor can be converted into water if about the large scale it is being produced. Okay, in that case it can be helpful for getting the water itself. But in the lower capacity, the water during the fuel cell operation it evaporates. Okay, so this over there, the technology used in the generating electricity is called the fuel cell. The fuel's chemical energy is directly converted into electrical energy, and you will not believe this kind of the technology means hydrogen to fuel cell and fuel cell to electricity conversion efficiency is around 98%. One of the most efficient energy electricity means neat and clean electricity you can get from these processes. Now let us discuss about what is the strength, weakness, opportunity and threats of electric vehicles. Okay, strength, zero harmful emission. मैंने already discussed earlier कितना harmful है. Electric vehicles do not release the harmful emission during the operation. This is related to operation, means the tailpipe. From the tailpipe, there is no emission like conventional vehicles. Okay, so because of that reason, the greenhouse gas emission using electric vehicle and plug-in hybrid electric vehicle led to 32 and 46% reduction in the CO2 emission respectively. Okay, and urban noise impact. Noise वाला भी बड़ी problem है. In urban area, at a speed of below the 50 km/h, electric vehicle positively impact on the noise level. The 10% of fluid in the speed and 6% fluid in electric vehicle will go to the acoustic vehicle alternating system. So this is another good thing about electric vehicle. Okay, and lower maintenance and operation cost. Yes, this is perfectly true. However, but this is true in case because the movement there is less movement as compared to this conventional vehicle, right? So many things are needed over there for cooling engine, radiator are needed. So all those things are no need right in the water and many things for in case of the conventional engine. Okay, electric vehicle has a lower maintenance and operation cost in comparison to uh, conventional electric vehicles. Okay, so a greater energy efficiency. मैंने energy efficiency का आपको example दे दिया. The electric vehicle comes with a much greater efficiency. Most of the energy generated by the electric is efficiently converted to the yeah. This is transfer to the wheel and contributing fast accelerating in motion. I mentioned earlier. Okay, the performance advantage electric vehicle offer a much faster accelerator compared to the internal machine. Already all these things. And some weaknesses are there. Electric vehicles can recharge. Electric vehicle can be recharged using plug socket, but process in time is consuming. And domestic मैंने अपना personal experience बताया आपको. Increasing number of electric vehicle contribute the high power demand and causing the change. This electric. अब ये एक बात. हमारे कंट्री में अभी हमारे पास एक्सेस इलेक्ट्रिसिटी है. This is another fact. ठीक है. So if suppose all the vehicles are converted into electrical vehicle or battery electrical vehicle, so there may be such kind of power crisis. Okay, we have to prepare. We have to prepare our own infrastructure regarding this. Okay. So this is another weakness. The initial purchase cost and electricity remains relatively high and hindering the widespread adoption. Of course, the cost is cost of the electric vehicle as compared to conventional vehicle is high. The lithium-ion battery used in electric vehicle at temperature sensitive and operation in between the 15 to 35 degrees. But in case of our country, few months back, I was in committee that was constituted by Delhi government. You might have also heard few DTC buses will catch fire during summer season. Okay, so in that committee, I was there, and in fact, you will not believe, almost in every season, more than 50 buses will catch fire. Battery operated vehicles, or in fact, the DTC buses. Okay, the public transport in the public transportation. So, in one season, more than 50 buses will catch fire. That was due to because of the RV. Okay, cooling was not there. And in fact, in few cases, when the cases were investigated, the case to case were investigated, then in some cases, the sparking was also another factor for catching that fire. Okay, but in most of the cases, the improper cooling of battery series. That was so. Battery thermal management is another important area. So you people may work during your minor or major project battery thermal management that you can do with the help of console or ANSYS. Okay, so you may take some whatever the available in passenger car or this commercial vehicle, right? So that you can do that exercise for your countries. So this lithium-ion battery temperature and in fact the ambient temperature in Bhopal I have almost 14 years I have already I have been here in Bhopal. So I remember the temperature can reach up to 46, 47 during during June or May, not in April and May. In fact, in Delhi, yeah, 49 temperature we have observed in the last few years. Okay, so how would you cool? Actually, cooling is done from the ambient air only. Okay, so maintaining temperature 35 degree during that period for 1 or 2 months, May and April and May is really very difficult. Okay, so so this you people can take this problem for your major minor major project. So product exposure of the temperature above 60 degree can lead to thermal running and legal because the exposure is high. And in fact, ये क्या होता है? मैंने आपसे एक बात की थी शुरू में कि there are two terms, energy density and power density. And lot of development is taking place, and we have to. Our aim is to reduce the size, reduce weight, and at the same time increase its power capacity. Okay, right? तो क्या हो जाएगा? 60 डिग्री पहुंच गया तो it will be like बम बन जाएगा, है ना? ठीक है ना? तो ये है. So in the last 4 or 5 years, definitely a lot of development has been taking place. बैटरी का साइज भी कम हुआ है, उसकी एनर्जी पावर डेंसिटी भी इंक्रीज हुई है, ठीक है? At the same time, even one of my students, Chetali, she is working with the air type battery in the University of North Carolina. Okay, so actually I was not aware about by the time, but few days back I have discussed with her. So her PhD is in air. So they are developing the air-based battery over there. And so in fact the lithium battery, if suppose they would success in terms of the power density, so such kind of battery will definitely replace this lithium ion battery. However, at present time, this is only the solution, right? So product exposure or temperature above 60 degree can lead to thermal running with the lithium explosion fire. Okay. Okay. So what are regarding opportunity? Proper end of life solutions for EV vehicle tech are crucial presenting economical opportunities to be addressed. Wireless charging technology has been potentially developed. We have to work lot of work. We have to do a lot of work in that area. While wireless charging may propose change in terms of the peak load, it also offers the opportunity to enhance the great flexibility and efficiency, particularly in going with the other systems like this. Okay, so smart charging technology enables the control over the timing and magnitude power supply EV of benefits such as congestion management. Okay, and regarding threats, raw material for the battery production. Yes, for timing we have sufficient lithium ion battery. Electrode array on the key material lithium ion nickel, lithium ion manganese nickel and natural purified. For few decades we have. Then later on what will happen? So current reserve is sufficient for the meeting the demand for the next decade. But after that what will happen? So this is another step. So limitation in meeting the 100% electrification demand. So despite adequate the raw material, there is challenge in meeting the demand of 100% electricity in the transportation sector. Emphasizing the need of recycling material extraction. Okay, so recycling is related to battery bank. Okay, so material, we have to work on the material which can be recycled. Otherwise, definitely there will be very serious problem because of this discarding of this battery. Okay. Okay. Then limitation in meeting the 100% electricity demand, despite of adequate raw material, this is challenge in meeting the demand 100% electricity in transportation sector. Yeah, that's yeah. Need of the recycling is motivation for electric vehicle development. The surge in electric vehicle development and driven the environmental concern, the aim to reduce the greenhouse gas emission and loss and fossil fuel reliance. Okay, definitely. This is because in India, fossil fuel, as we know, we are only having around the 22%, or in fact, the 82% we are importing from the Middle East or some country, and even the coal we are importing from Indonesia. Right. So. battery production, the production of lithium-ion battery is not entirely okay. Process is not emission free, highlighting the need of the continued improvement of production method. So these are some limitations basically. Okay, this is another part. Now this EV charging. That's so basically three four. I divide my talk into three to four part. If you want to have rest for 5 minutes, then you may take that, but permission you have to take from your mentor. Okay, if it is required, otherwise you can continue. Yeah. So let us talk about the charging infrastructure. Most established markets focus on the residential charging. Internationally, 50 to 80% of all the charging events occur in the residence. Lack of resident charge availability is often found in the area of EV adoption. मैंने अपनी बात बताई उसकी सब है. Residential charging can use a level of 1 or level 2 EV supply equipment. Okay. Regarding public charging, public and home charging, less expensive to install and operate. The AC charging power is limited to the capability of vehicles on board charger. Can process payment and data, can be networks, expensive to install, the faster charging, these are the requirements. Okay? Can process the payment and data, can. So this all infrastructure is needed. Okay, incompatible with many two or three. Okay, yes. ये बैटरी स्वैपिंग. अब इसमें कौन राजी होगा? मेरी बैटरी मैंने आज खरीदी है, आप साथ कर लेंगे. मैं कहूँगा मेरी बैटरी 3 साल पुरानी है, अब स्वैपिंग कैसे कर लूँ मैं? इन्होंने खरीदी है कल. ये बहुत बड़ा डिस्प्यूट है इसमें. The government of India framing some policy in this. However, many countries, Taiwan, China, Japan, they have already framed. And in fact, this is possible for one company. भाई एक्साइड वाले एक्साइड में बदले या नेक्स्ट वाले को बन गया वो अपना वहां से रिप्लेस करें. ठीक है, उसकी अच्छा. बैटरी के केस में बैटरी की कंडीशन क्या है? ये बहुत इंपॉर्टेंट है. जैसे मैंने कहा मेरी 3 साल पुरानी है, उन्होंने ये कहेंगे भाई मैं पुरानी कैसे ले लूं? गैस का सिलेंडर होता है घर में, वो रिप्लेस होता है. गैस खाली हो गई, अब क्योंकि वो स्टील का बना हुआ है, माइल्ड स्टील वगैरह का है ना, स्टील का ही है, स्टील तो मटेरियल का, उसमें कुछ ऐसी कोई चीज नहीं है नया पुराना. ठीक है, लाइफ तो उसकी, लेकिन जितनी उसकी लाइफ है उसके बाद उस पीरियड के बाद वो डिस्कार्ड कंपनी ऑलरेडी कर. ठीक है, गैस का सिलेंडर बदलना बड़ा आसान है, सबका सेटिस्फेक्शन है, लेकिन बैटरी कैसे चेंज करें उसके लिए आप पॉलिसी वो एक. ठीक है, तो चलिए ठीक है सर. So easier for motorcycle scooter because of the life size and less expensive. Has used a multiple battery but can be more compatible with the renewable. Reduce the upfront cost and scooter increase the large network operated by the Taiwan, China, and this Honda, KTM, Yamaha have formed the swappable battery constantly. So as I told, the company means specific this vehicle industry will have their own battery swapping companies, right? So इसमें बड़ी सहमति बनाना बड़ा मुश्किल है. So there are some EV policy will frame with from some country. I will just read out. How much time is there? 1 hour completely I have. Okay. So this in China. Subsidies and incentive. In fact, this is very important thing. ठीक है, जब तक आप किसी को जैसे दिल्ली गवर्नमेंट ने अभी 2 साल पहले एक पॉलिसी निकाली कि आप लीजिए, तो कुछ उसमें सब्सिडी बहुत अच्छी खासी थी, तो मेरा रोड टैक्स वगैरह कुछ था अच्छा खासा, मेरे को ऑलमोस्ट 70,000 या 75,000 तक का आपको मिल, आप जब भी अट्रैक्ट कर पाओगे. ठीक है, उसमें definitely आप long term planning करके चलें. Government definitely मैंने कहा कि of the adopting of electric vehicle or battery operated vehicle are basically shifting of environment. Right now, unless we are charging from the renewable energy sources. Recently, we have written our research paper finding the optimum location of a battery charging station renewable energy based, or in fact, mainly this is the solar photovoltaic energy based battery charging station in Delhi. Okay, so it is hopefully and it is in operation research. Recently, we have submitted revised manuscript. I hope within it will accept very soon. So in that such kind of analysis for India for some other place we can do. Okay, so like subsidy and incentive, the Chinese government offered the subsidies to both the manufacturer and buyer. Okay, both manufacturer and buyer of electric vehicles to make them more affordable. Local government often provide additional incentives such as the exemption from the incentive from the trade lottery and the social credit. And another way is to promote electric vehicle. क्या हो सकता है? मोदी ही टैक्स लगा है, environmental tax, conventional vehicle. जिस पे भी IC इंजन बेस्ड व्हीकल है, उस पे environmental tax लगा दो, एक और टैक्स लगा दो उसके साथ. तो लोग जो है व्हीकल्स खरीदना शुरू करते हैं और वो टैक्स काटते हैं उसकी सैलरी से, जैसे इनकम टैक्स काटते हैं ना, ऐसा नहीं, चॉइस नहीं, और वही हमें डिडक्ट करते हैं. तब पॉसिबल ये रिकॉर्डिंग तो नहीं हुई ना, हो रही है. अच्छा, सवाल भी बोलना पड़ेगा. ओके, क्या होता है दिख नहीं रहा. अच्छा, so mandate and rules. Under this, the China implement a new energy vehicle policy credit system which require automakers to work with certain number of credit for producing selling vehicles. Automakers filing to case the fine, okay, and court case fine is basically on the purchase the credit or and collaboration with the industry. The Chinese government collaborated with the domestic and international companies to increase the deployment of electric vehicle technology. Joint venture partnership for to accelerate this. Okay, so battery technology development is afford to invest the research and development in advanced battery technology to improve the performance and affordability of this infrastructure. The Chinese government invested heavily in building charging infrastructure to elevate the anxiety of operation. So the Chinese government have done a lot of work for promotion of this emission standard, the stringent emission standard. मैं इसी में भी आता environmental tax लगाने के लिए, है ना? Stringent emission standard was set for traditional vehicle to increase adoption of the cleaner alternative, including the government fleet electrification. Government promote the adoption of electric vehicle, taking more fleet example of regulatory support and regulatory. So like in this way, many countries have framed their policy. Norway, incentive, tax break, import duty on the electric vehicle are lower as compared to the traditional vehicle. Electric vehicle more affordable. Okay. So public charging infrastructure, investment in the widespread public charging infrastructure making convenient for electric vehicle. Okay. Bus lane, zero emission. The commitment to promoting zero emission vehicles setting target percent in new car. Okay, so like in this way, all the awareness, education, research and development support given by the Norway government. Similarly, USA in USA government substantial tax break incentive and purchasing electric vehicle, including exemption of value-added tax and reduce the annual vehicle tax. Toll tax exemption. See, the toll tax exemption and reduce the very fare for the electric vehicle. So such kind of the attraction must be there. So import duty again they have contemplated lower as compared to this. Public charging infrastructure, bus lane, the zero emission commitment. Okay. Okay. So Netherlands again they have tax incentive, reducing the of the registration tax. The vehicle registration charges are they have waived off to make them more cost competitive as traditional. These are the basically the policy or tricks to attract the buyer. Okay. So company car taxation incentive and tax benefit companies employ the electric company car including the lower taxation rate. Okay. So yeah, exemption of the road tax. Exemption or reduction in the road tax in the electric vehicle further reducing the cost of ownership. Home charging subsidies support the subsidy for the individual installing home charge station, making it more convenient EV owner. Okay, so I think this way, the Sweden they have again the exemption from the vehicle taxes, incentive subsidy given by the Sweden government, the company car taxation, the tax incentive the company who have chosen the this vehicle is company as well. Okay. So lower tax, public transport facility electrification, green car level, spatial identification, green car level for electric vehicle to assist the specific privilege benefit for free park space. Okay. ये बात है ये दिल्ली में मुझे बहुत अच्छा है लेकिन दिल्ली the parking is really very big problem है ठीक है so urban planning and zoning the education awareness again the infrastructure development in India. India का थोड़ा पढ़ लेते हैं ना अच्छे से. So in India, what the government of India framed the policy for promotion of this electric vehicle, right? So this frame basically is a faster manufacturing of the hybrid and electric vehicle scheme. It's a government initiative aimed to incentivize and the adoption of electric and hybrid vehicle. It provides financial incentive for the purchase of electric vehicle and support the development of the charging infrastructure. Incentives subsidized the various state in India offer the incentive or subsidy for purchase of the electric vehicle to make them more affordable in consumer. Do we have any such kind of policy in Madhya Pradesh? है कोई?
Not yet.
Not yet. Okay. So the goods and service tax, the GST benefit, the reduced goods and GST tax for the electric vehicle makes them more competitive and traditional vehicle. And public transport and initiatives to electric public transportation, including bus and two-wheeler, to reduce emission and promotion. आपने देखा ही होगा मेरे ख्याल से जोमेटो, स्विगी, they जो भी supplier हैं वो they generally having electric vehicles. नहीं है दिल्ली में तो है यहाँ पे शुरू हो रहा है अभी हो रहा है तो वो रीजन यही है because they are saving some tax Sweden और Zomato है ना so अच्छा initiative to electrify the public transport including bus two-wheeler and to reduce the emission to promote the electric vehicle and mass transit urban planning and infrastructure integration of electric vehicle infrastructure the urban planning and development project including infrastructure development to consider the need of electric green number plate. This is for the identification. Introduction or distinct green number of plate electric vehicle for facilitating the differential treatment such as assess the certain lane and parking space. It is clear. Okay. अब पता नहीं कहाँ हमने देखा है. Import duty and reduction import duty for component used in the manufacturing the electric vehicles and support. This is for manufacturing basically. Manufacturer. This benefit is for manufacturer. Education. Public awareness campaigning and the education program inform the public about the benefit of the vehicle and address the concern this misconception. Okay, so this now let us connect our vehicle with renewable energy. As I already told you, at present we are charging of electric vehicle is from conventional energy sources. And conventional energy sources, most of the sphere is conventional energy sources of fossil fuel. Okay, so in fact, they are India is blessed with the solar radiations, solar energy, and as well as wind energy is there, biomass is there. Okay, so of course, as per data, government of India data, 40% installed capacity of power generation is from renewable energy sources. Okay, almost 40,000 megawatt installed capacity is from the solar energy, and 38 or 39,000 megawatt is from wind energy. Okay, so more than 84,000 megawatt comes from renewable energy out of 400,000 or 4 lakhs megawatt, right? So let us have a discussion on the how renewable energy integration with the electric vehicle technology for sustainable development. वही sustainable development की बात करें. What is sustainable development? In sustainable development, we have the 17 goal, right? क्या है sustainable development का? वो यही है, सिंपल सी बात है. In simple word, we have to use all the whatever the natural resources we have to use it very carefully, consistent and with conscious, so that the next generation can have the benefits of all or accessibility for next generation. क्या है रीजन, कैसे कर सकते हैं? That you can do by effectively or efficiently utilization of whatever resources are available. हमको जो भी resources हैं, natural resources, that we have to use or exploit very carefully, है ना? So sustainable development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And of course, over there, the efficiency improvement is a major thing. Okay. So, Kofi Annan, our biggest challenge in this new century is to take the idea that seems abstract, sustainable development, and turn it into the reality for all world. Kofi Annan, former Secretary General of United Nations, right? So living within our environmental limit is one of the central principles for sustainable development. The focus for sustainable development is far broader than just the environment. It is also about ensuring strong, healthy, and just society. This means meeting the diverse needs of all people, existing and future community, promoting personal well-being, social cohesion, and inclusion, and creating the equal opportunity. Sustainable development goals are blueprint to achieve the better and more sustainable future for all. Okay, so how can we do this integration of renewable energy with EV? What are different resources? Hydropower comes under the category of renewable energy. In fact, small, mini, micro, eco type of power hydropower distributions are generally comes under the category of renewable energy. But the large type of the power plant like Narmada or say dairy hydro development, dairy hydropower plant, those doesn't come under the category of renewable energy. However, renewable water is being used for the power production. The reason is being because for the last capacity of the power plant, hydropower plant, you need to disturb ecology. Okay, so because of that reason, this large power production from hydropower is not considered. Okay, so in hydropower, the global share is 44.4%. And what are the advantages? Natural abundance, higher lifespan, technical maturity, high power capacity, and drawbacks. The secondary emission during the installation. During installation, definitely large capacity of turbine and this during construction, huge construction material is needed. Of course, for battery for cement. One of my scholars is working on energy conservation and opportunity in cement industry. And two papers we have already been published. One recently come in the cleaner production. Another one is process safety and environmental protection. So he done very nicely that all the analysis and simulation and validation of that. The implementation of solar energy or the in cement industry in India, in Indian cement industry. Okay, so that so of course cement industry is very energy intensive. Lot of lot of energy is required in their different sources, right? So definitely this second emission during the installation, the local inhabitant relocation. This is another problem. I remember when dairy hydropower plant was constructing in the near Tiri, in fact the Tiri, the old town of the Tiri. Lot of Sundarlal Bhamura, you might have heard one environmentalist was the Sundarlal Bhamura. He used to protect to stop that burn. And in fact, the old TD town was completely shifted to new TD town. And generally, what happened, and people generally shift from one place where they grown up, and especially the old people, they have their emotional attachment. Okay, so that region was there, and in fact, so local inhabitant relocation is major problem, disturb aquatic environment because large area is needed for dam for water reservoir. Okay, so increase the precipitation, increases the precipitation and flood and erosion. Yes, this is another problem. Okay, because the nature is disturbing. So at the same time, wind energy, the global share is 25.16% advantage. High technical maturity. Now wind energy conversion system, nothing is left to do. Fact is that many people are still doing PhD in the wind energy conversion system, foil, everything, and in fact, and even assessment of the wind power is also doesn't have any scope because data, many advanced techniques are available. Nothing to do. Very precise systems and modeling softwares are there. Okay. So in fact, this is quite mature technology, the wind energy. Yeah? So high technical maturity, the easy of installation over the land, easy of installation, easy of installation over the land and water. Very mature technology. In Holland, Norway, even they have they covered the all most of the part of their sea. High power capacity. What is the drawback? Affect the wildlife because of the sound. It creates a different kind of sound that these birds may divert from their path. Okay, this is definitely affect the wildlife. Water intensive maintenance, bird fertility, the large land acquisition, the intermittent, susceptible to strong noise pollution. Here are some problems with that. Solar PV. It contributes to 25% approximately in the global share. Advantage easy installation. आज की डेट में पीवी पे भी करने की बहुत कुछ नहीं रहेगा. Almost saturate हो गई इसकी. है ना? Unless कि आप कोई कुछ नई फोटो सोलर सेल आप डेवलप कर रहे हैं, है ना? Means the single crystalline silicon based solar cell is basically during its fabrication, it creates a lot of problems. Lot of chemical is released. All kind of the land pollution is there, water pollution is there. Okay, so many kind of problems are arises during its fabrication process. Lot of chemicals is being released into the environment. Okay, so but now it is very easy to install. Or everything is available ready-made. In fact, you can install within a week any large capacity of the power plant, solar photovoltaic based power plant. You can install within a week. Nothing. At eco state, you can easily design the solar photovoltaic system in eco state. Okay, it is freely available. Okay, so in fact, variety of the solar photovoltaic modules are available in the market. Right. So So technical maturity is there, relatively low maintenance. Yes, there is no very low maintenance. Only, and in fact, if you periodically you are cleaning the surface of this, and it will give you continuous means it will give you steady this efficiency. However, this efficiency of solar photovoltaic systems is very less. It is not more than in the real field. It is not more than 11%, right? It is not more than 11%. However, the China, in Japan, some lab they have claimed 42%, but it is not possible because many factors, many environmental factors are okay, and especially in Indian environmental conditions. Okay, so so yeah, relatively low maintenance, longer life. Yeah, 20 year longer life is there easily. But with time, its efficiencies reduces because of this decrement of this transmissivity of this cover. Yeah. In Indian climate, lot of dust is blowing. Okay, so surface of the this glass is getting okay. So this is another problem. Anyway, what is the drawback? The soil deterioration, large land acquisition. It is needed. The intermittent of the less efficient, the toxic material deposition during fabrication, the carbon footprint due to the manufacturing transportation is higher, and high replacement cost. Now, I remember almost 20 years back, the installation cost for 1 megawatt plant was 17 crore. But now it is reduced. The 1 megawatt plant is not more than 3 crore or lesser than this. At the same time, one threat is there. Though we have installed a lot of solar photovoltaic plants, but major problem with India is still there. We are heavily dependent on our neighboring because we are not manufacturing at all. However, the government, Modi government have this VLSI and lot of they have done lot of efforts, and maybe in the coming year, within 10 years, within 10 or 20 years or 5 years, we will have some manufacturing plant in India. Okay, we can have the semiconductor and all other. They have done a lot of creative from other country, right? But at present, we are heavily dependent on our neighboring country for supplying of solar cost-effective solar photovoltaic module. We are so far we are not able to reduce the cost-effective solar photovoltaic module. Even though we have installed more than the 2,500 megawatt capacity of solar photovoltaic system, right? But still we are looking at, and all are imported from other countries. This is major problem, right? अब आप कहेंगे गवर्नमेंट प्रॉब्लम बता रहे हैं yes, solar thermal power, this power generation from the solar thermal, though we have many applications, the low temperature, medium temperature applications, but power generation is from tower plant, solar tower plant. Helios are there. You might have heard that some reflector mirrors are there. They keep on breaking towards and focusing on the boiler, one storage device, a thermal storage device is there, and it is very integrated structure connected with the heat exchanger, and the heat flow is there. And in fact, halides are being used for solar thermal energy storage system based on the halides. Because the very high temperature is raising. The temperature is raising in around 500 to 600 degrees centigrade. And at that high temperature, we should have a material that can sustain up to 8 in a very high temperature. And at very high temperature, no, the oxidation is taking place. Okay, the environmental oxygen becomes harmful for that system. Okay, so and in fact, tracking and many devices are involved over there. However, government of India is also promoted a lot. But I remember 2, 3 plants in India based on the CSP, the concentrated solar power plant, whether this is the linear fractional type or tower type. Sorry. Okay, but they are not. Unfortunately, they are not working efficiently. Okay. So because of that reason, you just see over there the global share, and in fact, in advanced or developed country, they have stopped their research on CSP, concentrated solar power, right? And yeah, so, you can consider the highly efficient, very long life, you have low maintenance, stationary, low intermittency, and the drawbacks are the impact of the molten salt, the halides, effect on bird, yeah, because of reflection, the expensive installation, because of tracking, 2 axis tracking is required over there, okay, and distortion nearby the scenario, the water intensive maintenance, because you need to clean all the time. In Indian environment, we have a lot of dust over in all the seasons, right? So that if dust is deposited on the reflector, definitely it reduces the reflectivity. So we have to clean that. Some cleaning devices have already developed, but lot of the water intensive, lot of water is required, and of course the vacuum based water this cleaning device is needed. Okay. Uh, Water intensive and intense energy storage dependency, yes, because solar energy is intermittent source of energy. During daytime, you will have solar radiation, okay, and in a certain period of year, like this rainy season, you will not have. So you need to have that much of backup of the solar thermal energy for producing this steam. Because after producing steam, the rest of the system is based on the like conventional system, right? So energy intensive dependency, the high initial cost, the initial cost is very high. Yeah. What is the need of integration of renewable energy into EV? Although we have already discussed all these factors, that we need the sustainability and environmental benefit, reduce dependency on the fossil fuel, energy independence, peak load management, grid stability and resilience, cost saving, promotion and decentralized energy system, intensive energy renewable investment, technological innovation, positive public perception. Okay, so yeah, that I have already electricity. The transportation industry is the second largest source of carbon dioxide emission from burning fossil fuel. The sector of transportation account the 28% of greenhouse gas emission released in the United States and 25% of gas released in the European Union, mostly caused by the state of the control system and transportation. Okay, because of that reason, we need to shift over renewable energy being created electric vehicles. So the necessity of this separating transportation from the CO2 must therefore be seen in this consideration. Percentage of energy consumed by transportation activity in the entire world climbed to 34.8% in 2019, most of which is from the fossils. Okay, these are some products because of that reason we want unification of renewable energy system to EV. Reducing carbon emission and pursuing carbon neutrality in the transportation sector is necessary step in our plan to achieve the global target. Okay. So these are basically because of that reason. These are the factor which force us to move towards the renewable energy system based EV. Okay. So, how much time I have? 30 minutes. Okay, I will cover one more topic. Okay, I will cover one more topic. Okay. Because EV, if you want to have the electric vehicle, the future is only the fuel cell based. And fuel cell, when we talk about the fuel cell, it means hydrogen requirement is there. Again, there are many types. Again, there are many kinds of hydrogen: gray hydrogen, green hydrogen, blue hydrogen, right? I'm talking about green hydrogen. Green hydrogen means hydrogen is produced with the help of renewable energy sources. Means green energy sources, right? So, hydrogen production is again is very challenging and very cost intensive. Okay, however, the technology almost matured, and now the cost of production of the hydrogen varies from uh, around roughly the point 0.4 to 4 US dollar. I will show you one picture over here. Okay. So, in fact, if you remember, hydrogen, the energy density of the hydrogen is 140 to 143 megajoule per kg. On the other hand, petrol, diesel, gasoline, give me 42 megajoule. Maximum good quality of it is not more than 50 megajoule per kg, right? So, more intensive energy intensive, more energy, energy density is nuclear fuels only have a higher energy density from this hydrogen, right? So, basically, the uh, production of hydrogen is again a very energy intensive process. And if suppose we are producing hydrogen with the help of renewable energy, or say better solar energy. Okay. Why I am saying solar energy? Because in India we are blessed with the solar energy. All right. Uh, so what is basically the electricity production is there. Electricity is produced from the solar photovoltaic system, and it is, as I have already told. Now, electricity production from the solar system is not costly. It is much more comparable to the conventional energy system, because the cost of electricity production from fossil fuels comes around um, uh, 3 rupees 50 paisa, and cost from this comes around 4 rupees. So that much difference only, right? So what we are doing over here, electricity, by splitting the water basically, and water we have abundantly water availability is there. Okay, ठीक है, तो freely available है ना, अभी तो free है, बिकेगा नहीं, पीने का पानी तो कितना है, बहुत कुछ free है, ठीक है, उसको verify करके that we can convert it into hydrogen, right? Okay. So, in this section, I would like to talk about history, how hydrogen is saved. एक बड़ा मिथ है हाइड्रोजन के बारे में, बड़ी डेंजर है ना, हाइड्रोजन बम की वजह से. It is danger if suppose the leakage in confined space. यहाँ लीकेज हो जाए और सारी खिड़कियां दरवाजे बंद हैं, then only it is danger. Otherwise, if suppose ये खिड़की खुली है, वो cross ventilation is there is no harm, there is no problem, because it is dispersive nature, highly dispersive. ठीक है ना, अगर एक्यूमुलेट हो जाएगी तब आग लगी, तब बम विस्फोट हो जाए, तब एक बात दूसरी है, अदरवाइज इट इज हाईली डिस्पर्सिव. ठीक है. सो दिस इज, अब देखो कुछ एक्सीडेंट हो गए दुनिया में, तो उसकी वजह से तो डर रहे हम सब, है ना. हाइड्रोजन डिमांड, then hydrogen cost, then hydrogen application, next storage method, objective, then if time permit, then I will discuss all these. बड़ा छोटा है। So hydrogen has been recognized as a substance over the 2nd century. In 16th century, the first from the Switzerland discovered the gas and formed during the reaction between sulfuric acid and iron. Okay, and in 1970, in 17th century again, this building from the same country, that is Switzerland, the Robert was produced the hydrogen from reacting iron filling and dilute acid. So basically, hydrogen initially the hydrogen was producing with the help of the iron filling and diluted acid or sulfuric acid. Henry again the hydrogen as a unique substance in 1770. So history is not so old. 16th century, and it was discovered in the 16th century. The Henry chemist identified the hydrogen in unique ways. Anthony Rivers, in 1800, the English Nicholas that first time electrolysis. This Nicholson and Charles has used the first time the electrolysis process. Okay, and this is the most well-known process for the electrolysis. In 1839, the British scientist Sir William Robert developed the first hydrogen-powered fuel cell. अब देखिए फ्यूल सेल की कहानी कोई नई तो नहीं है। 1839 में we have discovered that hydrogen based fuel cell was discovered in 1839. ठीक है, 1839 almost 180 years back. कितने 160 170 साल पहले हम ये कर चुके हैं। अच्छा, later on the German scientists invented first balloon in 1900 that used the hydrogen element in the policy of the electric air. These are the airship to cross the Atlantic were put into the service during 1920 and 30. The US NASA had founded the 1950 to pursue the space exploration and made a great historical contribution to hydrogen. It employed the hydrogen as a fuel. Was the world's first largest liquid hydrogen in 1961. The first space shuttle was launched in 1981 the Soviet Union by the time Soviet Union. A flight with the U-155, the world's first jet engine aircraft that used the liquid hydrogen in 1988. So 1988 में Soviet Union ने space में जो shuttle launch किया that was based on hydrogen. Hydrogen has often been synonymous with danger due to the extremely flammable nature, especially since Hindenburg disaster on the May 16, 1937, which killed 35 out of 96, 97 passengers on the airship. कुछ ये एक्सीडेंट हो गए, हिंdenburg का एक्सीडेंट हुआ, मैं कार से हो रहा है ना, almost the 37 people were died. ठीक है, ऐसी कुछ एक्सीडेंट हो गए, तो उसकी वजह से प्रॉब्लम तो हुई है। तो ये how hydrogen is safe? Hydrogen is non-toxic. See, hydrogen is non-toxic, mild and much lighter than air. It dissipates. What I was saying, that it is diffusivity is very high and dissipation rate of dissipation is very high. Dissipation rapidly when it is released, allowing to relatively rapid dispersal of fuel in case of the leakage, which make it relatively safer than other species. Right? Preliminary safer concern is that if it is leaked, the gas undetected and gas collected in the confined space, if gas collected in the confined state, it can eventually ignite and cause explosion. In the confined space, right? A thorough understanding of the hydrogen property and designing the safety feature into the hydrogen system training. In fact, the training in the safe hydrogen story and the hydrogen practice are key element in ensuring the safe hydrogen. The US Department of Energy stated that in the website, as more and more hydrogen demonstrate get underway, the hydrogen safety record can grow and build the confidence that hydrogen can save the fuel while specifically. In fact, जितना ज़्यादा हम यूज करेंगे, उतने ही ज़्यादा फेमिलियर होंगे, उतना ही हमारा कंडीशन है। Ultimately, energy source तो आपका हाइड्रोजन है, right? Because of its specialty of its energy based, right? And in fact, it can be produced from various ways. In fact, biomass is another very promising raw material for producing hydrogen. How? Biogas, CH4 is there. However, it is right now at present, it is not cost effective, very costly. Okay, And gasification is another way. In gasification, S2 is there, S2CO has a higher volume. Okay, producer gas or syngas is there, right? So there, yes. See the application point. Application. Very sorry. मैंने अपने आज सुबह ही एक दूसरी स्लाइड से इसमें मैंने किया क्योंकि कुछ कनेक्टिविटी में बनाना चाह रहा था because of that reason this font size is very small. Now just look at over here. This blue, this yellow part is basically this is the application of hydrogen. Application the 51% application the share is for is this utility of the hydrogen is for production of ammonia, and ammonia is being used in the many industries, even for fertilizer, for producing the fertilizer, and oil refining, methanol. Okay, in oil refining also it is a 31% share is from oil refining, and the methanol is 19%. Okay, so there are many, and in fact, the demand is keeps on increasing in these industries. Okay, whether this is oil refining or this is ammonia production. Okay, so this SO demand is increasing every day, every year, being widely used ammonia production 51%, oil refining 35%, and methanol production 10%, and remaining 8%. Recently, most developed countries using the S2 as a transportation fuel. S2 being used for the fuel cell to generate electricity and water, and this water vapor, in fact, for the small capacity water vapor, could be the problem as a greenhouse gas, but in the large scale, the water vapor can condense, and it can water can be the byproduct, like glycerine in case of diesel, biodiesel. In biodiesel, glycerine is a byproduct, but in case the large capacity for in case of the fuel cell, this water vapor can be condensed and water is very right. So in fact, the water is another very fresh water is in fact is needed. Now, considering the future need the H2 demand of the H2, it is important to find a route to reduce the production cost. So production cost, of course, right now it is a bit higher. Okay. Global energy demand keeps on increasing. Just see the trend, and in fact, this is the most of the global hydrogen production. Most of the global hydrogen production is natural. Right now, the natural gas is being used. The 48% natural gas is being used for the hydrogen production, and coal is utilization coal for production is 18%, and oil is utilizing for the hydrogen production 30%, and water is 4%. Okay, just see this is see the trend for global energy consumption, and in fact, hydrogen you can produce with the help of the different energy sources. It could be the nuclear heat, okay, nuclear electricity you can use, and the renewable energy, solar photovoltaic, hydro wind, and that photovoltaic, hydro wind, and that these kind of energy, these kind of energy you can use for the electrolysis and hydrogen can be produced. Of course, solar thermal and biomass also, natural gas, coal and supply. So this is the supply. You need to supply these energy sources, these energy sources to produce the hydrogen, and this is for demand or application side. The industry, the turbine, IC engine, process synthesis, power generation. Okay. In the fuel cell, tertiary, regeneration, commercial, the fuel cell based IC engine, fuel based engines, and IC engine. So demand side, there are a lot of demand of the hydrogen in the different industries over there. So this is basically the relationship between the supply and demand of the hydrogen. Okay. Now the cost. Let's talk about the cost of hydrogen. H2 will play the key role in shifting the global energy system towards the sustainable energy system by 2050. And Hydrogen Council 2020 has demonstrated that hydrogen has been grown drastically in 2020. It has the potential to unlock. It has the potential to unlock the 8% of the energy demand with production of 2.5 USD per kg of hydrogen. Right? By 2030, the H2 cost is expected to lower lower 1.8 USD per kg as compared to this. Okay, and it can be unlocked. The possibility is unlocked of 50% of global energy demand. The cost of S2 is very widely zero point 0.8 to greater than 4 USD kg per kg in the different regions. So these are the different regions. Just look at over there, and the lowest cost is somewhere in the South America. I forget his name. In one place is I think in nearby Peru, one country is there. Bolivia, Bolivia, I think. Bolivia is there. So they are only the 0.8 to 3.6 is the lowest hydrogen production cost is there, and this you may not be able to see these all, but I will provide you this APT, so don't worry. So this is basically the cost of the hydrogen at a different region in the world. Okay. So this is again this is split of this European part. Europe have European production. The major H2 consumption is in Europe, and then America, then Asia also. Further, the Asia, East, West, and South Asia can be converted. Okay. And various costs are involved over there in the hydrogen production, operational costs, cash flow, and harder inventory, the total investment, there are different direct, indirect costs, and different costs are there. And ultimately, our aim is to reduce. Ultimately, our aim is to reduce the hydrogen production cost, plant profitability, and competitive economies. Okay. So this is our aim, and ultimate aim for the production of hydrogen. And you see over here the importance of hydrogen in parts of various energy sector. And in fact, just look at over there the renewable energy. This is the grid basically, electric grid. And electric grid, electricity is feeding from the different sources. They are the different sources feeding into this, and this electric grid, the electricity from the electric grid can be utilized for the hydrogen production. But just see over here again producing power from hydrogen power generation. If suppose this is true in case of if you have an excess amount of hydrogen, but right now we don't have the excess amount of hydrogen, right? So this group from hydrogen again utilizing. So this path is basically can be utilized as a energy storage. Okay. But right now we cannot say this because once electric because again once electric because in electricity you cannot store battery through battery you can store the electric. In fact, the charging and discharging capacity is different, and in fact a lot of losses are there. Okay. So this route is then possible when you have the excess amount of energy, excess amount of hydrogen. So then only the hydrogen storage can be utilized. Energy storage we can do this way. Okay. So ultimately, the hydrogen is being produced, and hydrogen is utilized for the production of this fertilizer, synthetic fuel, and petrochemical and transportation sector. Okay. And for heating up. So the various applications are there. Hydrogen is mentioned between hydrogen consuming industry, for example, the ammonia, ethanol production, other sector industries such as electric grid, transportation, agriculture, energy storage. Consequently, the numerous production choice to be available flexible, right? So these are the different hydrogen applications. Okay, so we have got different energy sources: nuclear, oil, wave, coal, wind, solar, biomass. You can produce the hydrogen and then further the hydrogen. Then hydrogen can be utilized for the production of power and the different power for the different applications, whether it is transportation, consumer, for different end users. Okay, so that you can do. So these are the different way of the hydrogen storage method: physical and chemical storage. And physical storage can be segregated, can be categorized as compressed hydrogen tank, liquid hydrogen tank, and the cryo compressed hydrogen tank. And the further the chemical storage, metal hydride, can be absorbent. These are the different ways to store the hydrogen, right? What should I do? Should I stop? because students are maybe it is long time to say. Anyway, anyway, just please have patience for not more than 20, 10, 15 minutes, and we can have some discussion if you want. Otherwise, it's okay. Okay, so hydrogen storage cost. Just look at over there. This hydrogen storage cost is another big important thing. The compressed gas storage, liquid gas storage, and the better hydride storage. So least one is basically the cost of storage is compressed gas storage is 17.9 rupees per. These are all figures in the rupees per kg of the hydrogen, right? So like in this way, and in fact, liquid hydrogen you can store in a more cost effective way, at 2.16 rupees per kg of the hydrogen, right? Uh, so definitely some risks and security issues are there because hydrogen being the lighter, coefficient of diffusion and lower density, much more safer. In addition to specific heat, has to efficiently reduce and increasing temperature. Like in this way, so these are very fundamental basically. And in fact, hydrogen, you can produce the hydrogen with the help of the classic this solar energy. And these are the three routes. Basically, hydrogen production can be done by the photochemical method, thermochemical method, and electrochemical method. Right. So photochemical method further classify the photobiological processes there, the and thermochemical process again, solar cracking is there, reforming, thermochemical transformation of biomass. So these are the different groups and a chemical process, right? So ultimately, aim is to produce hydrogen with the different groups. There are the different groups for utilization of solar energy for production of the hydrogen, right? So basically, this is the photochemical. This is photochemical radiations are converted into specific panel. Then the electrolyzer is there. The electrolyzer split the hydrogen and oxygen, right? So this thermochemical process, what we do over there, the thermochemical side, there direct thermolysis of the water and sugar cracking, acidification, reforming, and hydrocarbon. And these weather depends on the concentrated solar radiation that we can easily, as you know, the up to you can produce the temperature up to 1500 degrees centigrade with the help of the solar concentrating device. And because the concentration ratio is very important factor, you can easily have the concentration ratio of in the range of 1200 to 1500 for producing high temperature, right? So these methods depend on the concentrated solar radiation to produce the high temperature through solar device called the endothermic reaction. The various kinds of device can be used to achieve the higher solar concentration ratios, such as the tower. This is tower system, parabolic dish, and solar furnace. Okay, so very high temperature up to 1000 degrees temperature you can easily achieve. But the condition is you have to make sure the material should sustain at very high temperature, right? So this is but rest of the thing. So this is the concentrated solar radiation, and basically this is thermolysis process. So water is split into hydrogen and oxygen. This is another way. But over there, the very high temperature, you have to create very high temperature. That is during daytime, during sunshine hours, that you can achieve very quickly. Okay, this thermolysis process. Please. Yeah. Okay, this is another solar cracking of hydrocarbons. So solar thermal cracking of the hydrocarbons again the formation of the co-synthesization of the CO2 and H2 and the black carbon. The hydrogen production from methane decomposition lines and the separation of methane was permitted in the temperature 2100 Kelvin from the reactor. So this major, because in this case the major challenge is to design this reactor. Okay, so solar cracking and this reactor capacity and in fact this design of the reactor is very challenging over here. So hydrocarbon can be hydrocarbons can easily split into the H and C. And over there, this C is very This is the black carbon. Okay, so like this is the byproduct black carbon, but it has a very utility in the many industry, entire industry. Black carbon is used. Okay, so again, this is the steam reformation. But as I told my one of my scholars is working the steam reformation. Solar is in fact the solar steam reformation to the heart of solar energy, right? Steam reformation technique is developed in the and very good research paper in the International Journal of Hydrogen. He has published. Okay, so reaction takes place in the pressure range in the 20 to 30 bar with the high temperature 840 to 950 temperature. Okay, so this is another way, and in fact the steam reformation method reforming the operation through the solar reactor and attain the methane conversion approximately 87% efficiency. It is efficient, it is 87 with the S2 and the molar fraction is 49.3%. Okay, so this is a simple process of the steam deformation of natural gas. This is another method for producing the hydrogen with the help of biomass. Okay, in biomass, of course, the drying should be there to reduce its moisture content. And the thermolysis, for the thermolysis, the hydrogen heat, solar energy heat you can supply, and this drying is taking place up to the 150 degrees centigrade. And the thermolysis is 500 to 600 degrees temperature by the time. And further the heat, further the heat at the high temperature is supplied over there. The gasification process is done, and further there is this solar heat 900 to 1100 combustion, purification, and different chemical energy, chemical reactions are involved over there. So with this way, finally you can produce the hydrogen over there. The synthesis, synthesis gas, CO, S2, and SH2, like in this way. This is the one of the method for producing the hydrogen from biomass. Okay, so this is electrochemical process. Okay, over there is a diaphragm, and this is anode and cathode. This is electrolyte is filled over there. Okay, and the chart. So this in this electrolyte and the PN, the photon exchange membrane is basically over there. That shows the various technology from the water electricity. This is very promising technology. And one of my friends in Renewable in CSMCRI, he's working over there. And in fact, Germany have done a lot of work on this photon exchange based membrane for development of the membrane for splitting the water into the hydrogen and oxygen. Okay. And the main commercial advantage of reactor is the hydrogen production by the scalability and the zero emission production. Okay. So this is a another very promising technology. So at the end, just I want to summarize. So efficiency of converting solar energy into electricity is a major barrier to improve this efficiency. And in fact, instead of the solar thermal, the solar photovoltaic is much more as compared to much more efficient. So high temperature method requires additional battery development. That I was saying. High temperature method requires additional battery development, focusing on the high temperature and membrane and heat exchange of the solar process. Global solar hydrogen system mainly consists of the solar hydrogen system for transport and the stationary application. Environmentally friendly production of the hydrogen using the solar energy is very important for protecting the environment, since no greenhouse gas generated during its production, right? And the low energy efficiency of photovoltaic generator, and hence the overall energy efficiency of solar hydrogen is currently basically this is challenge for the researcher. Overall energy efficiency is low. Okay, so numerous renewable energy sources have their own social and environmental issue that need to be addressed. However, all these obstacles are being actively addressed by the organizations and industry. Okay, for further investigation. So this is all about from my side. However, there are a lot of things we can discuss. Okay, many people have already worked on the solar-based hydrogen production. Okay, these are the different references. Many people have done the review, and many people have already done this research for themselves. They have worked on the energy and efficiency and calculation performance wise and how much it is efficient. Okay, so just see over there, the energy and efficiency, energy efficiency is quite high. Okay, it can be energy efficiency can be the 46% and energy efficiency up to 22% itself. So by this way you can produce, and government of India have also taken good initiative for development of the green hydrogen. Okay, so in dairy, dairy means the Tata the Energy and Research Institute dairy has predicted that demand of the hydrogen will increase 6 metric ton to 28 metric ton by 2050, and the cost of hydrogen from renewable will fall 50% by the 2030. So people are working on that too, and in fact under the Make in India program, India has a project to start the production of the electrolyzer and fuel cell, which will allow the capturing a large share of the market in the worldwide. Okay. So government of India is also promoting for the production of hydrogen with the help of the renewable energy. Many Indian institutes, including the Indian Space Research Organization, Indian Oil Corporation, BHEL, Tata Motors, actively involved in the hydrogen and fuel cell technology. Okay. So ongoing development by the Indian government and public organization create a lot of opportunity to become a major player on energy sector. Okay, this is these are some benefits. Basically, the reduce the petroleum import and energy security, decarbonization of the sector, integration of the renewable energy and hydrogen production, address the climate change issue, and just look at over there. India has total installed renewable energy. Wind, this is quite old, and at 2023, the solar energy is higher than wind energy. But the trades, just to replace the solar energy, wind trades are reducing. Okay. So this is basically a fuel space hydrogen fuel cell, hydrogen fuel stations. Only India is having only two hydrogen fuel cell stations, one in Nigeria and another one in Nice. China, US, Germany, Japan. Just look at over here, number of hydrogen refueling stations. Yes, picture is in front of you. Japan, the sea, lot of initiative they have taken. Japan, Germany, US, China, and we are at the least. But government of India is doing very nice work. And in fact, Indian Oil R&D in the Faridabad and Nice, the National Solar Energy, National Institute of Solar Energy in Gurgaon. Okay, they have. These are some government of India initiatives. India has taken the initiative to National Green Hydrogen Mission to become the major exporter of the hydrogen and the incentive. The initiative is studying integration of the hydrogen program. Okay, so with this, I would like to stop here because there are many things to discuss. If you have any query or have, we can have some discussion. All of you are welcome. Whatever we have discussed over here from EV technology, then integration of renewable energy, then production, of course, the future is the hydrogen fuel based EV vehicles, right? So in that way, I would like to stop right now. If you have any query, then we can have discussion. Otherwise. Yes. हाँ कोई बात नहीं, हिंदी हमारी राष्ट्रभाषा मातृभाषा है, हिंदी नहीं बोलेंगे तो कहाँ बोलेंगे? मुझे भी समझ में आएगा हिंदी बोलोगे तो। बोलो।
जैसे सोलर पावर का है।
हाँ, सोलर पावर।
तो सर जैसे सोलर पावर सर सूर्य से होती है लाइट, उससे सर सूर्य से जो लाइट आती है,
हाँ, सूर्य से
एनर्जी स्टोर होती है उसकी, तो बैटरी में स्टोर करते हैं ना सर उसे कम।
नहीं, देखो ऐसा है, सोलर एनर्जी जो आ रही है ना, सोलर एनर्जी बेसिकली सोलर रेडिएशन जो आ रही है, दीज आर शॉर्ट वेव रेडिएशंस, ठीक है? शॉर्ट वेव रेडिएशंस है, सोलर से आ रहे हैं, ठीक? फिल्ट्रेशन हो रहा है थ्रू एटमॉस्फेयर, फाइन। अब इसको हमें यूटिलाइज करना है। How can we utilize? There is one way is to convert it into direct DC power through the solar photovoltaic. And another way is to convert it into heat energy. Then further that heat you can apply for either heating application, or further that heat energy you can used to produce the steam, and the steam is used to run the turbine. The turbine finally connect with the alternator, then power production. Power production we can do, right? And storage. Now you want to store the solar energy basically. So solar photovoltaic, whatever the solar power is produced through the solar photovoltaic way, that you can produce with the help of the best way right now is available is battery, right? And in fact, other way also you can store the solar energy in terms of the thermal energy. Thermal energy you can store with the help of sensible heating materials, phase change materials, and some other chemicals are available. Okay? So these are the way to store the solar energy. अब मुझे अपना और दूसरा अगला सवाल बताओ।
सर मेरा एक सर इसमें आइडिया सर जैसे ज्यादातर जो धूप पड़ती है राजस्थान में पड़ती है
बिल्कुल।
तो सर जिसके लिए सर हम यदि जैसे इलेक्ट्रिकल जो व्हीकल चल रही है सर ऑटो, तो यदि इसके ऊपर सर हम यदि सोलर पावर की प्लेट लगाकर इसे डायरेक्ट एनर्जी को स्टोर कर सकते हैं बैटरी में और उससे हम व्हीकल चला सकते हैं।
बिल्कुल कर सकते हो आप। लेकिन क्या हो रहा है असल में क्या है ना, सोलर एनर्जी बहुत डाइल्यूट फॉर्म है ना। तो एक आपने देखा होगा कि रेडिएशन आ रहे हैं है ना, और रेडिएशन दे आर फॉलिंग ऑन सम प्लेट है ना, यू नीड लार्ज सरफेस है ना, that is basically dilute form of ये dilute and intermittent source of energy. These are the two disadvantages of solar energy. ठीक है, but still अब आप क्या कर रहे हो, आपने कहा कि व्हीकल के ऊपर आप सोलर फोटोवोल्टिक मॉड्यूल लगा दो एंड थ्रू दैट बैटरी चार्जिंग। ठीक है, बैटरी से आप पावर ड्रॉ कर रहे हो थ्रू इन्वर्टर।
सर यदि उसमें दो बैटरी रखी जाए यानी जो पहले से चार्ज है उससे ऑटो चले
और एक आप चार्ज करने के लिए रखो पैरेलली उससे चार्ज हो। ठीक है, अब सवाल यहाँ उठता है कि अब अगर रिक्शा भी है ई रिक्शा में चार लोग बैठाएंगे, पांचवा हो गया ड्राइवर। ठीक, अब बैटरी का वेट भी बहुत होता है, यही वाली बात मैं कह रहा था। बैटरी के केस में देखो तीन चीज बड़ी इंपॉर्टेंट है, वेट, वॉल्यूम और इसकी कॉस्ट। ठीक है, दो तरह की चीजें होती है, पावर डेंसिटी और एक एनर्जी डेंसिटी। अब इसमें क्या होगा कि जितना कॉम्पैक्ट बैटरी होगी उतनी ही ज्यादा हमको चाहिए। रिसर्च इसी पे हो रही है, कॉम्पैक्ट आपको बैटरी बनानी है, कम उसका वॉल्यूमेट्रिक एफिशिएंसी, ग्रेविटेशनल एफिशिएंसी है ना, यू नीड टू इंप्रूव किलोवाट पर केजी, किलोवाट पर वॉल्यूमेट्रिक है ना, इन दोनों को आप रिड्यूस कर दोगे तो डेफिनेटली कॉस्ट इफेक्टिव बन जाएगी। ठीक है, तो व्हीकल डिजाइन में आपको वेट टू पावर इज ए वेरी इंपॉर्टेंट। ठीक है ना, ठीक, वो सब आपको ध्यान रखना। ठीक है, एनी अदर
सर इट इज पॉसिबल।
हाँ, that is possible. Parallelly you can do, but please take care of the weight.
Sir, can we produce hydrogen through mineral acids?
Hydrogen from mineral acid. See, basically hydrogen is produced from the sulfuric and metals. Right? This is a conventional, but it is not possible. And in fact, in that production, environmental is degraded. So better way is to either electrolyze or thermolysis. Split the water. हाँ, SCI, diluted sulfuric acid, diluted hydrochloric acid, उनको आप जो फिलिंग्स होती है, मेटल फिलिंग्स जो वेस्ट होती है उनमें आप अटैच कर सकते हो। लेकिन फिर क्या करोगे, आप फेंक दोगे, और क्या होगा, उससे फर्टिलिटी बहुत बेकार हो जाएगी सॉइल की, है ना। भाई हमें एनर्जी तो प्रोड्यूस करनी है, बट वी हैव टू टेक केयर द एनवायरमेंटल, वी हैव टू कंसीडर ऑल द एनवायरमेंटल प्रोडक्शन।
तो ऐसे जो जनरेट होता है उसको भी करूंगा H+ और Cl- में कन्वर्ट कर सकते हैं।
नहीं बिल्कुल सकते हैं, मैं ये नहीं कह रहा, बिल्कुल आप भाई इनिशियली 16th सेंचुरी में हाइड्रोजन बनी है, लोगों ने डिस्कवरी ऐसी करी।
Both are very important gases. Hydrogen as well as fluorine is also as
नहीं, सल्फ्यूरिक एसिड जब आप फ्यूम्स आएंगी, these are not environment friendly,
yes.
है ना? So best method is to use the water. Water can be split by either way, ठीक है ना?
And sir, जो solar energy generate होती है, जो हमारे solar plate होते हैं,
सोलर फोटोवोल्टिक मॉड्यूल,
तो जो sun के थ्रू जो हमारी light आती है, sun rays जो आती
जी,
है, basically they can get
Photons.
three type of rays, infrared rays, UV rays.
solar spectrum is wide range spectrum. Ultraviolet or the ultraviolet rays are there, visible rays are there, and infrared radiations are there.
So which type of rays are used in
Only visible. The bandwidth in between 0.4 to 0.78 micrometer. आपने अगर आप जब देखोगे आप स्पेक्ट्रम इस टाइप का होता है, that is only needed for us. That is only needed for us. Infrared basically it creates the heat. If suppose the temperature of the solar cell is more than 25 degrees centigrade, it degrades the productivity of the DC power. जैसे जैसे टेम्परेचर बढ़ता जाएगा वैसे वैसे आपकी प्रोडक्टिविटी पावर जो है पावर प्रोडक्शन भी ठीक है ना? एनी अदर? हाँ बताइए
सर। ये पूछना चाहता हूँ मैं, जो चार्जर रहता है तो बैटरी को हम चार्ज करते हैं।
हाँ चार्ज करते हैं
सर, तो पहले वो 2 घंटे में चार्ज रहती है ना, फिर समय के साथ साथ देर से चार्ज होती है, 3 घंटे में, फिर 4 घंटे बढ़ते जाता है।
क्वालिटी डिग्रेड होती है, बैटरी डेप्थ ऑफ डिस्चार्ज, डेप्थ ऑफ डिस्चार्ज, क्वालिटी, यही तो डेड एंड कहाँ पे आएगा बैटरी का। क्वालिटी ऑफ द बैटरी डिग्रेड विद टाइम, सर्टेन साइकिल्स आर देयर बेसिकली। भाई एक बैटरी है, चार्जिंग और डिस्चार्जिंग उसकी सर्टेन साइकिल के लिए लाइफ है ना, विद टाइम इट डिग्रेड्स, ठीक है। उसमें बहुत सारी हैं, प्लेट्स हैं, वो कोरोड हो जाएंगी, है ना, बहुत सारी चीजें हैं। तो वो यही लाइफ है, ये तो नेचुरल फिनोमेना है। ये आप कम करीब आप मतलब अमर तो कोई भी नहीं है ना, ठीक है। तो यही है तरीका, भाई उसे रिड्यूस कर दो, लाइफ आपकी उसकी थोड़ी बढ़ा दो, इस द वे, ठीक है। बैटरी की चार्जिंग डिस्चार्जिंग द डेप्थ जो लाइफ है आप उसको इंप्रूव कर सकते हो, लेकिन अल्टीमेटली एट द एंड ऑफ द डे इट विल डाई। वही मेजर प्रॉब्लम। और ऑफ कोर्स जैसे सोलर फोटोवोल्टिक मॉड्यूल है, उसकी टाइम के साथ साथ उसकी एफिशिएंसी कम होती है, इसी तरह इसकी भी चार्जिंग डिस्चार्जिंग एफिशिएंसी आल्सो रिड्यूस।
तो बैटरी रिसाइकल नहीं होती सर बैटरी?
रिसाइकिल हो सकती है, प्लेट चेंज कर दो, ये चेंज कर दो, ऊपर का कवर रह जाए तो क्या होता है। हाँ ठीक है भाई, कवर भी तो आपको बनाना ही पड़ेगा, उसमें भी तो एनर्जी एक्सपेंसेस होंगे ना बनाने में। सो अप टू सम एक्सटेंट यू कैन, दैट इज नीड बेसिकली। आफ्टर 3-4 years battery, whatever battery components are there, it should be recyclable. ये एक बहुत इंपॉर्टेंट चीज है, इट शुड बी रिसाइक्लेबल, देन ओनली द प्रॉब्लम ऑफ डिस्कार्ड ऑफ बैटरी, द वेस्ट जनरेटेड फ्रॉम द बैटरी विल बी सॉल्व्ड, ठीक है। वह ये एक तरीका है जिससे आपकी सारी ये समस्याएं जो हैं, जो अभी जो वेस्ट जनरेटेड फ्रॉम द डिस्कार्डेड बैटरी जो है वो सॉल्व रिसाइक्लेबल है चीज,
मतलब हो सकती है,
अभी चल रहा है,
तो एक्सपेंसिव होता है।
अब बताओ कितना बहुत इंप्रूवमेंट हो गया है ना, साइकिल्स में बहुत इंप्रूवमेंट हो गया, जब बैटरी की बहुत रिसर्च चल रही है। बस ये है कि एनर्जी डेंसिटी हम बहुत ज्यादा नहीं कर सकते, कम साइज में ज्यादा उसकी डेंस करेंगे, मैंने कहा ना बम बन जाएगा। हाँ जी बताइए।
जैसे कि वर्ल्ड में इतने सारे पॉलिसी और प्रोग्राम लॉन्च किए हैं ई व्हीकल को प्रोडक्शन को या मतलब उसके यूज को इंक्रीज करने के लिए, तो आपके अकॉर्डिंग सर इंडिया को कौन कौन से प्रोग्राम और पॉलिसीज को लॉन्च करना चाहिए?
इंडिया ऑलरेडी हाँ मुझे मैंने एक चीज बोली शुरू में, इंडिया जो है इन्वायरमेंटल टैक्स लगा दे, सैलरी से सीधा कट जाए,
एक्सेप्ट दैट,
बट एक्सेप्ट दैट मतलब ऑलमोस्ट अगर इंडस्ट्री साइड में कहें तो गवर्नमेंट ऑफ इंडिया गिविंग लॉट ऑफ सब्सिडीज, और हमको भी जीएसटी में रिबेट है ना। और जहां तक है अभी जो प्रॉब्लम मेन है, जो एक चार्जिंग स्टेशन की एक प्रॉब्लम है भी, कि गवर्नमेंट ऑफ इंडिया को थोड़ा वहां पर चार्जिंग स्टेशंस जैसे पेट्रोल पंप है, हालांकि वो पॉलिसी फ्रेम हो चुकी है, इम्प्लीमेंटेशन भी हो चुका है, लेकिन अभी बहुत ज्यादा फेमिलियर नहीं। अदरवाइज गवर्नमेंट ऑफ इंडिया हैव ऑलरेडी डन लॉट ऑफ एफर्ट्स, and in fact government is continuously they are doing a good job, okay, for implementation of this EV, to criminalize, to accept it, to enhance its acceptability in the public, ठीक है, धीरे धीरे होगा।
sir. And another question is, how do we use hydrogen as a fuel?
Hydrogen as a fuel in fuel cell. In fuel cell is a way by producing the electricity you can produce with the help of hydrogen. Hydrogen fuel cells are there, and you will find the conversion efficiency is there more than 90%. But that is the best way, and the byproduct you will get the water itself. ठीक है ना? तो ये मैं आपको बता रहा था कि ultimately solution is the fuel hydrogen based fuel cell is there for the clean or green energy supply and generation, ठीक है। हाँ जी, और
Okay. Thank you, sir, for sharing your time, knowledge, and passion with us. Your session has been an invaluable addition to this event. Now, may I request Professor Pradima Gangwar ma'am to kindly present a memento as a small token compared to the immense impact your session has had on us. Thank you, everyone. Students can go for the lunch.